Hey everybody. One of the most popular projects I've ever done in my life was my B-36 project. And to make a long story short, actually let's call this the backstory. I got it 99% done, and somebody made me an offer I couldn't refuse. And I've gotten a lot of heat for people that, from people that said, how could you sell it? At the time I didn't have a lot of money. But what this video is about, and let me press a button here. So what this video is about is it's an overview of a video series I'm getting ready to create, and it's going to take each of the major components of the B-36 and talk about how I designed and then how I developed them and built them. So today we're briefly going to cover the design, the fuselage, the Bombay, the wing, and all the components of the wings and the tail. But each of these subjects here will become its own little, probably 8 to 12 minute video. We'll dive very deep into why I designed it the way I did, why I built it the way I did, and if there was any testing involved, how that testing came out. So essentially, when I went to design the B-36, I used the same tools that I normally use, but at the time I didn't know about cubed wing loading. But when I do the data today, it would have had a wing loading of a glider because it had a 257-inch wing and a lot of square inches. I think over 5,700 square inches. Don't quote me on that. I'll put it down there if I'm wrong. But when you think about everything I've talked about in my other design videos, everything down the left is what you consider when you're designing a model aircraft of any size. But it really becomes important when you're building something this size. I drew the entire design in AutoCAD, and at the time I had 3ds Max as my 3D software, and I pulled all the parts into that and assembled it. So a lot of people think I design in 3D. I do for my 3D engines and all of those parts and pieces, but when I'm designing an airframe, believe it or not, I draw all in AutoCAD first, and then I will export that into 3D, extrude it, and assemble it and see how it fits. And if it doesn't fit, I go back into AutoCAD and adjust it. So here's the basically the fuselage and wing that I had pulled out of CAD and put into 3ds Max at the time. Now this has been pulled into Fusion 360 now, because with Fusion 360 I'm slowly pulling the whole B-36 into it, because it's going to get rebuilt one day. I am going to build another B-36 one day. It's going to be the exact same wingspan, 257 inches. It's a couple of years away because I definitely have to get my ultralight done first, and I have to build my Mosquito and an A7. But the B-36 will be coming. So the design, I knew at the time the AMA had a limit of 100 pounds. Now it's 125 pounds. I was going to build this entire aircraft at 100 pounds. And it wasn't going to be that hard, because if you've followed me at all, you know I love to use balsa wood and reinforce it with like carbon fiber. I only use plywood where I have to use plywood. And on electric, I don't need a lot of plywood for vibration. So when you think about the, basically when you think about all the drawings I did on this, there was about 1,000 hours, about 6 months, over 2.5 years that I did getting all the drawings as perfect as I could. And I know some people say, that's an awful lot of time. Well, there was a lot of drawing apart in AutoCAD, taking it into 3ds Max, seeing that it doesn't fit or it did fit, and then taking it back into CAD. There was building some components to see if it was really going to structurally work. So to get the drawings 100% done took about 1,000 hours. When you think about just all the different components that were in this airplane, and we're going to touch base on these, but we're not going to do a deep dive today. But these were just everything that had to be developed. If you look at the bottom left-hand corner, originally I was going to put the motor in the front of the wing and the prop, on the back of the nacelle. And I'll talk about that a little bit more in a minute, but I was going to do that for the center of gravity. Most radio control B-36s need 10 to 20 pounds of ballast in the nose to get the CG right. So let's talk about the Fuselage Design. Here's a picture of my son at the time, who was a lot younger than he is now. I mean, this was over 15 years ago, I think. Right now, I'd have to look, and I'll put that down there if I'm wrong on that. But if you look on the wall there, I had cut out what I call the truss, and I cut it out of plywood. And I did not like that at all because it was just so heavy. Now, the bulkheads I knew would have to be plywood, and this is all light plywood, L-I-T-E, light plywood from aircraft spruce. It's really light. And I only use it on the bulkheads and the ribs in this aircraft. Okay. Now, before we get too far, I want to talk about my sponsor, Rtl Fasteners. And I know if you watch my videos, you see how much I love this company. If you go to their website and you need fasteners, you know, blind nuts, servo screws, any of that stuff, go to the website, buy more than $50 worth of product, and use code DA30, and you'll get 30% off your order. Okay? And it's a really cool relationship I got with them. So now let's talk about the fuselage. So you just saw in that previous picture, I used plywood originally, and it was too heavy. So I decided to take balsa wood and build the structure totally out of balsa wood, with the bulkheads being that light plywood. And this was insanely strong. So what I learned really quickly is that we way overbuild model aircraft. We had to back in the day because we had either a glow or a gas engine that just vibrated. And I mean, it would just shake planes. So our mentality was always to build a strong enough plane. Plus, you want to have it so if you have a hard landing, you're not going to damage the airplane. Well, if you think about full-scale airplanes, flying a Cherokee, it's got a pretty beefy landing gear. But you land hard on a Bonanza because it's a retract, and you might damage those landing gears. So with model aircraft, it's the same thing. If you're going to build really light, you need to be a pretty decent pilot. But this airplane was going to have such a huge, such a low cube wing loading that it was going to fly in between a glider and a trainer. So there wasn't going to be that much shock unless you just really screwed up a landing. But as you see on the fuselage here, it was basically all balsa wood. And you can see some cardboard tubes here that were joiner tubes, because this was originally built in my basement and it had to go up a staircase. And when the fuselage was done, it was absolutely incredibly light. The entire fuselage weighed less than 7 pounds. It was crazy how light balsa wood is if you know how to build with it, and use some, strategically carbon fiber in the right places. When it was taken into the garage and then finally assembled together, the tubing in there was very thin wall carbon fiber, because once I skinned the entire airplane, and actually the tail here, I unskinned some of it because once it's in my garage, I wanted that skin to overlap that joint. And I hadn't thought about that when I was doing the original. Bottom left-hand corner, my daughter's bottom left-hand corner, my daughter's holding up that fuselage. And you can tell how long ago this is because she's 20 now. But that whole nose right there weighed less than, I think it was 22 ounces, right at about 22 ounces. Now, continuing on with the fuselage here, I want to talk about the Bombay door designs. I was able to get some really good, if you contact the Smithsonian Institute and ask them to give you information on the B-36, you can talk to I think it's the docents there, and you can actually pay and get some drawings. And a friend of mine who had been getting B-36 drawings from them got me some drawings of the Bombays, the way they really worked in the B-36. So, believe it or not, this was just slick as snot. These these Bombay doors worked flawlessly on the airplane. And you can see I had 2 servos down there on the front and aft of each set of doors, and these things were fast actuating and worked beautifully. The real B-36, believe it or not, had they called fast actuating doors. They would open really quick, and they actually close a little bit slower, if I remember right. If you want to see these operating, just type in DAG214 YouTube B-36, and I've got a lot of video of this aircraft in there, but I've never done a deep dive on the design. So what we're going to talk about now is the wings, and every part in this airplane was hand cut on a bandsaw. I do not have a laser cutter. So, of course, that took a monstrous amount of time. On the bottom left-hand corner there, you can see where I was using balsa wood spars, but I was using carbon fiber, and which became problematic because one of the problems I had that stopped part of the build on the B-36, well, I had two big things. First, the original landing gear that was being designed for me wouldn't fit in the wing, and I had to redesign another wing. So believe it or not, there was a wing 1.0 and a wing 2.0 for this plane. The same landing gear manufacturer completely screwed me on the weight of the landing gear, and I'll talk about that later on. Luckily, they've been sold and rebought, and they're not around anymore, the people that didn't know what they were doing with my landing gear. But one of the problems I didn't think about using carbon fiber, I know carbon fiber is it's the strongest when it's in tension. And on spars, it's great, but you got to think the bottom spar when it's sitting on the ground, that's in compression. So I had a little bit of a sagging problem with my wing. It flexed a little bit too much, wing 1.0, and my flaps were going to jam. So I had gotten around that, but then when I got the landing gear and they wouldn't fit, I just redesigned a whole new wing. When you think about these wings, the only thing plywood in them was the ribs. And the only hardwood was the landing gear blocks. And I used a lot of carbon fiber strategically to beef that up. I had people reach out and say there's no way that wing's going to work, and they didn't realize the plane was basically done, and I had tested the landing gear. So it worked, okay? If you're watching this and you think it's too weak, it worked. Okay, the landing gear worked. Now, I never flew the airplane and landed, but I did, and I'll show in a minute, I did some testing of the landing gear. So when you think about one of the hardest things when you design an airplane is actually getting landing gear to fit in the wing without removing too much of the strength of the wing. I've seen RC drawings of like B-29s where they cut into the spar and build like a box where the landing gear goes. That is a horrible idea. You want to try to get continuous spars to run tip to tip, and you want to be able to strategically put your landing gear either right behind that spar or in front of a spar. You never want to run a spar into a landing gear and then build a box around it and go on, because that box over time will get fatigued, made out of plywood. If you're able to make the box out of aluminum or maybe laminated carbon fiber, you might get away with it. But that's one of my pet peeves about people who design RC aircrafts but have never flown or built one. There's people who actually do drawings that's never built one and never flew one. So that's one of the hardest things with this. But I'm going to dive into this really deep when I do each of the individual videos. Ailerons. On the upper left-hand corner, what you see on the front leading edge of that is a dowel rod. That would be replaced with a hard, like piano wire type thing to be the counterbalance. I try to counterbalance all of my flying surfaces. If you look at real aircraft, they're normally balanced. That's the reason they don't flutter. So if you don't know about that, reach out to me. I'm actually going to make a video on flying surfaces. It's just on my list. But the ailerons on this were just slick as snot. They were just awesome the way they worked. Flaps. Again, I had all these people reach out and say, this is the most brilliant flap design I've ever seen. It wasn't my design. Basically, the real B-36 had flaps just like this. They had two swing like arms, and if you look at the geometry of the arms, when they went back, the flaps would go backwards and down, kind of like a Fowler flap. But this was just really, really super slick the way the flaps worked. And I'm going to dive into all of that. And as you can see here, it's in different positions. And there's 2 servos that would operate each flap. Keep in mind that's 12 servos. There's 6 flaps on this airplane. And when you just think about how the flaps fit in between the nacelles, everything on the real B-36 was about getting everything as tight as you could so it could be as clean as it could, to go as fast and be as economical on fuel as it could. It's a plane that was going to fly all the way to basically Russia and back without refueling. So now we're going to talk about the landing gear. And the landing gear was one of the most problematic things on this airplane. I reached out to a company early on and said, here's some drawings. I'm building the B-36. They sent me back some stuff and said this will work fine. Then when I went to order it, they actually looked at the drawings and said, oh, wait a minute, we didn't help. This is nowhere near big enough to swing the type of 4 wheels you're going to have. So I had a little bit of a heart attack about it. And then when they finally built the landing gear, they came in twice the weight they were supposed to be. took up twice the volume in the wing where the pivot mechanism is, and I just had to start all over. I had to redesign the entire center section of my wing. And since I did that, I redesigned the outside to make sure that the spars were just a little bit beefier. So when you're looking at that gear on the left there, the only thing that came from them is the pivot arm and the basically the strut. Everything else in there I made out of carbon fiber. Got rid of all the stainless steel, that like 1/8 inch wall. It was just way over. If you're going to build for an aircraft, everything's about weight. Everything's about weight. And you want to get it strong enough that you're not going to have a collapse. But you don't have to build it so strong that if you pile drive the airplane in, the landing gear is in pristine condition. Okay? So they had brakes on them. Everything about this landing gear when it was done was just super sexy. It worked great. But I basically replaced all the stainless steel in it with carbon fiber. And as you can see, it worked great. I had a sequencer for the landing gear door there. The wheels came from Glennis, which I don't think's around anymore. It's really sad, but Glennis made the best wheels at the time. So I don't want there to be any confusion. The people that built the landing gear had nothing to do with the wheels. Okay, the wheels came from Glennis, and one of the best, coolest companies I've ever worked with. But it sounded like 4 or 5 years ago they might have went away. I hope they didn't. And here's a little bit of testing of the landing gear I talked about. And here was what I call the brute testing, where I just piled on about 70 pounds of weight and would drop 12 inches, which was giving it some enormous amount of G-load that the airplane couldn't even survive, and the wheels were fine. And that's how I did it. Here is my initial design, where I was going to put a bearing on the trailing edge of the nacelle, put the motor in the front. I did a boatload of testing. I'm not going to go, this is basically an overview right now. I'm not going to go into everything I did on this, but here was a mock-up, and it worked perfect. But I got nervous. I didn't trust myself. Everything I do with model aircraft is the KISS principle, keep it super simple. This was so complex that, you know, the hatches to get it in and out of the wing and to be able to replace the shaft. And I finally made a carbon fiber shaft. I got this to work so perfect, but I was just scared of building an airplane that big with all the money invested in it and then these being problematic. I hate going to the flying field and having something broke on the airplane. You know, there's always jokes about airplanes that just sit on the tarmac and break. Just sitting there, they break. I hate that in model aviation. I don't want to be tinkering all the time. You know, every spring I do my annual on all my airplanes, and I want to fly the rest of the year with the minimal maintenance. So I was just paranoid. So what I did was I ended up mounting the motors on the back, which means I was going to have to put 12 pounds of weight in the nose of the airplane. Still, it was going to be on 125 pounds. It was going to be about 105. And I basically, and I'll do this when I do the deeper dive, I made some plugs so I could make molds. And then I pulled out of the molds the cowlings. This propeller here, believe it or not, was one I was going to use originally. But the manufacturer reached out to me about 6 months after I bought them and said, throw them away because we have them coming apart at the hub. And I said, okay. They refunded the money. They were really cool. But that is not the prop. I did test that prop, and I never had one come apart. But this prop was not going to be the one that was going to be used on the flying aircraft. And I'll talk more about props in a minute. Here's another picture of the nacelle with the spinner. And another. It was such a sexy airplane. Still to this date, I regret selling it. But you can't worry about the past. I needed the money. So now we're going to talk a little bit about the motors. It was Hacker A60-16Ls, which would turn a 2114 three-bladed prop. That's the pitch speed I needed. Now, keep in mind, I think this plane would have flown vertically if all 6 motors were put on 10S. I was going to fly this airplane on an 8S, which was going to give me about 2,500 watts of motor. Take that times 6, and that's a lot of watts. And the watt per pound on this airplane is going to be like 150 watts a pound. So it would have flown like a pattern plane probably, but it was the Hacker motors. I did do a lot of testing to make sure I got my prop speed and all that stuff right, And I wasn't really, as I've said in other videos, I don't care about the thrust. As long as I've got the RPM to get the prop speed for the pitch I've got for the way I want the airplane to fly, the thrust just comes along. Plus, most static props spinning aren't giving you what their true thrust will be when they're moving through the air. So now we're going to talk about the props. So like I just said, the 3-bladed props I ditched and ended up going with a Biela. Biela made 3-blade pushers, 14 pitch for me. They were and I still have them, most beautiful props in the world. Now keep in mind, the person who bought the B-36 is doing it for static display. So they were going to make props that look like true B-36 props. So I kept all these props and I kept the motors. They just bought the shell of the airplane. And we are going to talk about the jet pods. This was one of the coolest part of the airplane. And I definitely wanted 6 a turning and 4 a burning. And most B-36 that are built, that are models, don't. There is a B-36 flying out there that does now have working ducted fans in these, but basically this is to make my plug so I can pull a mold. This is after I pulled it out of the mold, and I'll dive into this when I do the individual videos, but that's what that looked like. That was all fiberglass there, and when they test fitting there, now the pylon was going to remain plywood, glassed, so I could get the wires done, and if the batteries were going to fit in the wing. And that's what they looked like when they were done. And I tested these. There's video on my YouTube of me testing these, and they were absolutely rock and roll. I will do a deep dive into this too. And now when we talk about the tail, the most interesting thing about the tail on this airplane is I had to build it as light as I possibly could because I already knew I was going to add a lot of ballast in the nose. So I went back to putting a carbon fiber tube in there to make sure it wouldn't fall off. But the elevators on this are like 20 or 30% bigger than the actual horizontal stab. And I don't know why the B-36 had such massive elevators, but if you look at it right here, that elevator was massive. And I can't imagine they had to pitch instability. But then I started thinking down the road, if they had 2 nukes in there, and they dropped 1 nuke out of the front Bombay or 1 nuke out of the back Bombay, how much would the CG moved? And did they need that big elevator to be able to trim the flying characteristics of the airplane with that big of a load being dropped from the front or the rear Bombay? And I bet I'm right on that. And then the vertical stab was just really basic and simple. And I'm going to do a deep dive into all of this when I do the other individual videos. But essentially, when the plane was done, it was ready to get the paint. It was just primed and got sold for static display. But as you can tell, it's awesome. Now, one thing I did that was bad on my part is I slowly started taking less pictures as I got it almost done. 2 reasons. One, I was really frustrated because this thing turned into like a 5-year project. It should have been a 2-year project. I had so many setbacks in this big aircraft. And I accept that when I'm developing something like this. But your frustration or your anxieties, the longer an airplane goes where it's not working, you know, the landing gear. I didn't trust my nacelle designs. I didn't trust the first wing design. All these things take time and money. I don't want to admit how much money I ultimately had in this project because it was over $13,000 I ultimately had in this airplane when I sold it, and well over that. And it's hard. I ran out of money. I bankrupted my hobby building this aircraft. And but when I build it in the future, I learned so much from this that I know it is going to be a million times easier to build. Okay, so, and I think I still got enough landing gear parts that I could still, I'm still going to have to machine a lot of parts, but I still think I got enough landing gear parts that I know how to build the landing gear a little bit better on this. And this was a picture of it sitting at Seth one day, all kind of assembled and put together. And it was about 8 months later that I had had it completely skinned up. And I was actually getting ready to do some taxi testing, because what I like to do is I prime an airplane and then I start doing some testing. I might even fly it primed because I want to make sure everything's right So if I got to cut open the skin or cut open an airplane, if you looked at most of my airplanes I've test flown, they're not cosmetically finished. They'll have the monocoat or the fiberglass on them. And that's another thing I'm going to talk about designing too, real quickly, because I know my videos go long. One reason my MSL2 is monocoated and then painted for detail is it's so much lighter than doing glass and paint. And I've done every experiment, and I've talked to a lot of my friends that do glass, and none of us have been able to do glass as light as monocoat. Just most people hate the look of monocoat. But most people don't realize, if you take like 12 or 1500 sandpaper and sandpaper the monocoat, you can paint on it and the paint will not come off. Okay? So stay tuned, everybody. There's going to be how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, probably 10 videos detailing each one of these things about the B-36 project. So have a great day, rock on, and be safe, everybody. See you next time.